Hi guys, this is Mr. Vertices. I'm going to be talking to you guys about linear programming today, utilizing the idea of linear inequalities. So a few things that you really need to make sure that you are solid on before you jump into this lesson is how to graph lines. Make sure you're comfortable with that. And then the other thing is that we're going to utilize is how to graph linear inequalities specifically. So that involves shading and whether your lines are dotted versus solid lines. So if you need to take a moment and look at that for a second just to get your head in the game for linear programming, feel free to do that and then continue on with the video. So the first thing that we have is this lovely word problem. So what's going to happen is we are going to have a word problem that we are going to base our equations off of, known as constraints. Once we have our constraints, we are going to be able to graph those constraints and shade appropriately. Once we shade appropriately, you'll be able to see where we go from there. So let's just start with the word problem. So we have a manufacturer of ice skates can produce as many as 60 pairs of hockey skates and 45 pairs of figure skates. So we have two different kinds of skates that this manufacturer produces. We have hockey and figure skates. So we know that we can produce as many as 60 pairs of hockey skates. And we know we can have as many as 45 pairs of figure skates. The other thing that we know is we know about labor. We know about hours it takes to make each of those. So we have information about hours of labor for hockey skates and hours of labor for figure skates. And we know that we have a total of 240 hours of labor available. So we normally have something which is an expression that we choose to maximize or minimize. And when we're dealing with word problems, that tends to be the profit information. So we're going to hold off for a second on this profit information. So the final goal is to find the number of pairs of each kind of skate the manufacturer should produce so that they can maximize their profit. So this is a key word right here, maximize. So we'll come back to that in a second, but we want to make sure that we are maximizing our profit, not minimizing our profit. All right, so the first step that we want to do is to define our variables. So if we look at the word problem, and again, feel free to reference it back, the last sentence will give you an idea of how to define your variables. So for us, we want to have number of hockey skates and number of figure skates. This is going to help you figure out how to label your axes when we are working with the graph of the systems. Once you've done that, we want to move on to our constraints. So our constraints, like I said before, were our equations that we based off of our word problem. So if we take a look back here a second, I underlined a few things. We know that we can have as many as 60 pairs of hockey skates, as many as 45 pairs of figure skates. We have 3 hours of labor for the hockey, 4 hours of labor for the figure skates, and a total of 240 hours available in total. So each of these I underlined is going to be one of our inequalities for our constraints. So we know we have as many as 60 pairs of hockey skates. So that means that what I underlined in red is going to be x is less than or equal to 60. It says as many as, which means that we can only have as many as 60. We can have less, but we can't have more, which means we have less than or equal to. Then we have the information about 45 pairs of figure skates. So again, similar to the hockey skates, we can have as many as 45. The next one we have is the information about the hours. So we know that we have 3 hours dedicated to hockey skates. We know we have 4 hours dedicated to each figure skate. And we know that we can't spend more than the 240 hours that we have total. The other two constraints that go unspoken or unwritten are these two that I'm about to do right now. These two are always in the background for when you're working with word problems, real world word problems. So we can never have a negative amount of product, skates, whatever we're talking about. So we will always end up having two equations that, again, are unspoken or unwritten, but are always present. So we know that we want more than or equal to 0 hockey skates. And then we also want to be greater than or equal to 0 for the number of figure skates that we have. So again, the red and the orange, peachy orange here, are the unspoken inequalities that we have to always assume are present. All right, so here's all of our constraints. So now one of the things that you want to try to do, especially for this guy right down here, the purple one, dealing with the hours of labor, is play with them a little bit to get them into y equals mx plus b. That will be easier to graph. So I'm just going to take a second and rewrite this guy in y equals mx plus b form. So now our next goal is to graph this. So we want to label our graphs. So I'm going to take a second and label my axes according to my variables that I defined in step A. All right, so using our variables that we defined in part A, we just labeled our axes. So now what we want to do is we want to start to graph our constraints. So two of our constraints are really straightforward. We had x is greater than 0 and y is greater than 0. So let's take a second and graph those. So now, as you see, we have our green inequality of x is greater than 0 and our orange inequality, which is y is greater than 0. We will shade after all of the lines are on the graph. So now I'm going to take a second and graph 2 more lines, the information about as many as 60 pairs of hockey skates and 45 pairs of figure skates. So in order to fit my graph, my lines on my graph, I made each box worth 3. So each of these go up by 3. So 3, 6, 9, 12. So this red line is at 60. This blue line is at 45. So then the last one that I have to graph is the purple line. So I'm going to take a second and do that. All right, so now I have the purple line graphed for us. So now the next piece, if you look at your notes, we are going to identify the corner points. So one of the things that we need to do first is figure out where to shade. So that means that we're going to look at our inequalities one more time. So for the green line, we want things that are greater than 0. For the orange line, we want things also greater than 0. So we're going to shade up here. For the red line, we want things that are less than 60. So we're going to shade in this direction. For blue, we want to shade less than 45. So we're going to shade in this direction. And we're going to find that when we figure out how to shade for the purple, we're going to be shading in this direction. So we want to look for where everything overlaps, and that's going to be in this trapezoid area down here. All right, so now that we have the shaded region, we want to utilize our knowledge of where we shaded to find our corner points. So we are going to focus on here, 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 and here. So I'm going to label these. I'm going to say that this is corner point 1, and then I can label this as corner point 2, corner point 3, corner point 4, and corner point 5. Our next goal is to figure out what these corner points are, so what the ordered pairs are. So for corner point 1, I was looking at the origin. So I was looking at where the orange and the green met. So the orange and the green were the inequalities. X is greater than 0, Y is greater than 0. So the corner point for 1 is very easy. It's just 0, 0, which is the origin. Corner point 2, if we look back for a second, corner point 2 was where the green and the blue lines met. So the green was X is greater than or equal to 0, and the blue was Y is less than or equal to 45. So this is another easy one. Our corner point number 2 is 0, 45. Corner point 3, if we look back for a second, corner point 3 was the intersection between the purple and the blue. So our blue was the easy one. Our blue was less than or equal to 45. Our purple was 3x plus 4y is less than or equal to 240. So you have to do a little bit of pencil pushing in order to figure out what the point is. So you have to utilize systems of equations when you're working. So systems of equations is going to come back to haunt you guys at this moment with linear programming. This one is easy because we just want to plug 45 into the other equation for y. When you do that, you're going to do some work on that, and then you should end up getting, again, check your graph, because if 20, 45 doesn't make sense in the location, then you probably did a little bit of math wrong. Next, we have corner point 4, where if we look back at corner point 4, that is the red and the purple. So the red is X is less than or equal to 60. And then again, the purple is 3x plus 4y is less than or equal to 240. So you have to use the idea of systems for this one again and plug in 60 for x to figure out your y. So if we do that, we find out that we have 60, 15 as our corner point 4. And then corner point 5, the orange and the red. So the orange was y is greater than or equal to 0, and the red was x has to be less than or equal to 60. So this one's, again, easy. No need to think about this one too much. Our corner point 5 is 60, 0. Okay, so now what we want to do with this is we want to test our corner points in our expression that we want to try to maximize our profit for. So first we have to figure out our expression for maximizing our profit, which means we have to visit our word problem again. So remember how we talked about money, and it tends to be the expression that we want to try to maximize, in this case maximize. we have a $12 profit for the hockey skates and an $18 profit for the figure skates. So we're going to use that information to create our expression that we want to maximize. So we said $12 for our hockey skates, and we said $18 each for our figure skates. So this is what we're going to plug our corner points into to figure out what our maximum profit will be. So now setting up a table of values is the best way to organize yourself. So now I have all my corner points in here from 1 to 5. So what now I'm going to do is I'm going to plug my corner points into the expression for my profit. So now I've plugged in all my corner points to my profit expression. So now I'm going to evaluate each of these and determine which one gives me the maximum profit. So taking a moment to calculate my expression with my corner points, I find the profits for each of the corner points, and the one that yields the maximum profit is when we have 20,45 in corner point 3. So now the last step for us to do is to interpret this. What does this mean? What is 20? What is 45? And provide a final answer. So the question that we're answering is, how many figure skates and hockey skates should the manufacturer make to maximize the profit? So we're using our corner point 3 of 20,45 to answer this question. So the way that we should report this is we want to say, to maximize profit, the manufacturer should make 20 pairs of hockey skates and 45 pairs of figure skates. Part of the question might ask you, what is the maximum profit? If we look back at the question in the beginning, the only thing that we were asked to determine was the number of pairs of each kind. So you do not have to state the profit, but make sure you pay attention to your questions, because sometimes it will ask you what the profit is as well. So make sure you include that in your final answer if the question asks that.